Students, this is called the Making Chalk Lab. And first I'll show you the equipment we've got. Two 250 milliliter size beakers, a 250 milliliter size Erlenmeyer flask, a funnel, a piece of filter paper, which will be very important, an electronic scale and a weigh boat, a glass stirring rod that has a little rubber tip that's called a rubber policeman, and a glass stirring rod that does not have that rubber tip, a scoopula, which can be used to move powders, a beaker with calcium chloride, a white powder, and a beaker with sodium carbonate, also a white powder. In the procedure, it says start by adding 50 milliliters of deionized water, which I have in this wash bottle, to each of two 250 milliliter size beakers. Actually, it's going to be faster if I just pour it. So I'm going to unscrew the lid, and then I'm reading on my beaker to the 50 milliliter line. Okay, that's one beaker. Same thing with this other one. Then we're asked to weigh out, it says precisely weigh out 2.50 grams of sodium carbonate into a weigh boat. So I'm going to open up my electronic scale. I'm going to wait for it to register 0. And then when it does, I'm going to put the weigh boat on it and then hit tare, T-A-R-E. Tare means put a new 0 at that point. Okay, so now my scale is reading 0. I'm going to take the beaker that has sodium carbonate and gently pour until I reach 2.5 grams. And it says dump the Na2CO3 into one of the beakers with deionized water, stir until dissolved. And then it says record the mass of the sodium carbonate in the data table. Precisely weigh out approximately is a term that means weigh out somewhere between 2.4 and 2.6 grams. Well, we had really close to 2.5 grams. We had 2.51 grams, but record the exact mass, okay? So I'm gonna add that to one of my beakers and stir until we dissolve. So we'll have a solution of sodium carbonate in one of the beakers. I'll come back and give a little more stirring in a minute. Then it says use the electronic scale to precisely weigh out approximately 3.5 grams of calcium chloride. So I'm going to put the weigh boat back on the scale, hit the tare button if necessary, but for me, it's right there at 0.0. And now I'm going to use the beaker that's labeled calcium chloride and pour out 3.5 grams. And we got 3.46 grams of calcium chloride. And that's close enough. As long as it's between 3.4 and 3.6, we're in good shape. Okay. It says dump the contents of, let's see, into the beaker, the other beaker with deionized water, stir until dissolved. So I'm going to finish stirring the sodium carbonate. And then, as the lab advises, I'm going to rinse the glass stirring rod with some deionized water. And I'm going to now stir We'll pause here for a second. Okay, students, so now we've got our solution of sodium carbonate very nicely dissolved. We have our solution of calcium chloride also very nicely dissolved. So if I'm following the procedure, we need to obtain a flask, a funnel, and a piece of filter paper. That's this round piece of paper. We're going to find the mass of the dried filter paper. So I'm going to use the scale again and set the dry filter paper on the scale. And I arrive at 10.8 grams. Then, if you follow the procedure, there's some pictures showing you how to fold this. This is going to be really important to do this the right way. We're going to take a circular piece of paper and fold it in half, so it's a semicircle. And then we're going to fold the semicircle in half so that you have a quarter circle. We're then going to put the funnel in the quarter circle form into the funnel, but I'm going to do it in such a way that there's one sheet of paper on the top and 3 sheets of paper on the bottom of the circular portion. Because if I had done this where there's 2 sheets of paper on top and 2 sheets of paper on the bottom, you'd have a hole in your filter paper. And since we want to trap the substance we're making here, we've got to make sure that it's 3 sheets of paper on one side, 1 on the other. And there's a little trick. Now that I've got the mass of the dry filter paper, I'm going to use just a little bit of water to get it to stick in the funnel. That way it'll stay nice and steady for us as we dump things together. Okay, so now we've got our filter paper set up in the funnel. We're going to use the flask just as a container to drip things into. It's just going to be a catching vessel. We're not going to measure anything with it. We're just using it as a place to capture the waste liquid. Okay, we need to dump the contents of one beaker into another. So the solution that contains sodium carbonate, I'm going to pour it into the solution that contains the calcium chloride. And what do you notice? Immediately, we form a solid white precipitate. Students, that was the reaction. We've produced chalk, calcium carbonate, by mixing sodium carbonate with calcium chloride. So it's like an immediate reaction. Now the challenge is to filter this. So we're going to slowly pour the solution that's in our beaker into our funnel. And we're going to pour. Maybe be patient a little bit and it'll drip through. And eventually what's going to happen is you'll be left with some solid precipitate coating the beaker. We want to get as much of that out of the beaker as we possibly can. And we want to use this to capture the sodium carbonate, the calcium carbonate solid that precipitated. Just pour vigorously here, pour amply. And as I'm pouring, I'm looking at the sides of the beaker. Now here's where the rubber policeman comes into play. I'm going to use the rubber policeman to squeegee out as much of the solid calcium carbonate as I can. All right, we want to capture that and get it into the funnel, which contains the filter paper. So if there's any solid white in the end, in the beaker, you're going to kind of want to get it out. You can also use deionized water as a rinse to help get out a little bit more of the calcium carbonate. So we're going to thoroughly rinse, and then you have to be a little bit patient, but we're going to let the filter paper do its job. I'm going to pause here because this can be a time-consuming process. And at the end, what we'll have is a wet piece of filter paper. And we're going to set it aside to dry overnight. And then when we come back, we'll get the mass of the dried filter paper, and we'll be able to do the analysis questions. Okay, students, so now we're at day 2 of the Making Chalk lab. I have here a dried filter paper with some calcium carbonate or chalk inside. I'm going to open up my scale, make sure it's reading 0, and record the mass. And we are at 12.98 grams. And that's it for day 2 data. We're going to record that, and then we'll do the analysis. Okay, this is the Making Chalk lab analysis. Our numbers from our data collection are these. The mass of sodium carbonate used was 2.51 grams. The mass of calcium chloride, 3.46. Mass of dry filter paper, 10.80. And the mass of filter paper with chalk in it when it was dried on day 2, 12.98 grams. Let's take a look at the analysis questions. It says, in the reaction for this lab, calcium chloride reacted along with sodium carbonate to produce chalk and sodium chloride. The formula for chalk is calcium carbonate. Write the balanced equation. So students, this is a question where they're just asking us to convert names into formulas and then balance the equation. It's something we can all do. So they're telling us we've got calcium chloride. In fact, I'll start with the word equation. Calcium chloride and sodium carbonate react together to produce chalk, which is calcium carbonate, and sodium chloride. This is a typical double replacement reaction where you have a positive ion, negative ion, the reactant side, and then they flip-flop the ions. So calcium now paired with carbonate on the product side, and sodium now paired with chloride on the product side. Do you know your polyatomic ions? Of course you do. Of course you do. You can refer to the periodic table to get the charges of everything except for carbonate. Carbonate ion is CO3 with a 2- charge. So when calcium ion, which is a 2+, pairs up with chloride ion, which is a 1-, the formula becomes CaCl2. When sodium pairs with carbonate, well, sodium's a 1+, carbonate's a 2-, so it works out to be Na2CO3. You need 2 sodiums for every 1 carbonate. On the product side of the equation, calcium's a 2+, carbonate's a 2-, so 1 ion of each will make a neutral compound, so CaCO3. Sodium's a 1+, chloride's a 1-, so 1 of each makes neutral sodium chloride, NaCl. We've written good formulas. Now, do we need to do anything to balance the equation? As it turns out, yes. The sodium chloride needs a coefficient 2 in front to make it balance. All right, so now we've got a beautifully balanced equation. That'll help us later on. Question 2. If all of the sodium carbonate reacts, what mass of calcium carbonate would you expect to produce? So if all of the 2.51 grams of sodium carbonate reacts, what mass of a different substance would you expect to see produced? Because this is a mass-to-mass conversion, we need 3 conversion factors: the molar mass of the first substance, the mole ratio, the molar mass of the second substance. Now, let's figure out some molar masses. I'll do some work over here on this portion of the board. And then we can refer to them as we tackle some of the analysis. So for sodium carbonate, formula is Na2CO3. 3 elements found in that formula, Na, C, and O. There's 2 atoms of sodium. And if I look on the periodic table, I can see that sodium's atomic weight is about 23. There's 1 atom of carbon, its atomic weight is 12. There's 3 atoms of oxygen, its atomic weight is 16. So if you add all that together, we end up with 106 grams per mole for sodium carbonate. What about, we're also going to need calcium carbonate. So let's find that molar mass as well. CaCO3 is the formula. We've got calcium, carbon, and oxygen. There's 1 atom of calcium. And if we look on the periodic table, you can either take a sheet or I'm looking at the wall and I see the atomic weight is 40.1. There's 1 atom of carbon whose atomic weight is 12. 3 atoms of oxygen with atomic weight 16. Add all of that together and we get 100.1 grams per mole for the atomic weight of calcium carbonate. Okay, so now back to question 2. If we know that 2.51 grams of sodium carbonate all reacts, what mass of another substance would be expected to be produced? Well, let's use the atomic weight of sodium carbonate of 106.1 or 106.0 grams of sodium carbonate, which is equivalent to 1 mole of sodium carbonate. Then we'll refer to the periodic table. I'm sorry, not the period. We will refer to the balanced equation where the coefficients in front of the 2 substances of interest to us in this question are both 1. So for every 1 mole of sodium carbonate that reacts, 1 mole of the chalk, calcium carbonate, should be produced. But then the question is, what mass is produced? So then we've got to go to the atomic weight of calcium carbonate. Well, we know that 1 mole of that substance is equivalent to 100.1 grams of that substance. And so if you follow the units, what happens here is grams of sodium carbonate goes away, moles of sodium carbonate goes away, and moles of calcium carbonate goes away. The only thing that doesn't cross out is grams of calcium carbonate. So you could pull out your calculator at this point, and this one works out to be 2.37 grams of calcium carbonate. So that's our expected amount of calcium carbonate if all of the sodium carbonate reacts. Question 2, if all of the calcium chloride reacts, what mass of calcium carbonate could you expect to be produced? So now we're going to look back to our data table, 3.46 grams of calcium chloride reacted. And now they want us to do the same thing here. We've got to get the the molar mass of calcium chloride. I'll show work over here. There's only 2 types of elements in that compound, calcium and chloride. There's 1 atom of calcium with atomic weight 40.1, 2 atoms of chlorine with atomic weight 35.5. And so we end up with 111.1 grams per mole. Okay, so if all 3.46 grams of calcium chloride reacts, and we know that there's a 100.1 grams per mole molar mass. And if you look back to the balanced equation and say, okay, now we're comparing calcium carbonate to calcium chloride. Again, it's a 1-to-1 mole ratio. So just like we had in the previous problem, now it's still 1-to-1 moles of calcium chloride to moles of calcium carbonate. And then to find the mass of calcium carbonate, we're going to use, once again, the molar mass we had figured out over here. 1 mole of calcium carbonate is equivalent to 100.1 grams of calcium carbonate. Once again, if you follow the units, you'll see that everything that you began with crosses out until you end up with what you want, what the question wants as a final unit. So grams of calcium chloride goes away, moles of calcium chloride goes away, moles of calcium carbonate goes away. And the only thing that's not crossed out is grams of calcium carbonate. To get the numerical value for the answer, I'm going to take my calculator here. And I arrive at 3.12 grams of calcium carbonate would be expected to be produced if all of the calcium chloride reacts. Those were two pretty big questions, weren't they? Question 4. Which reactant is limiting? So now here, we've done most of the work here. The reactant that's limiting is the one that produces a lower number of grams of the product. So we have 2.37 grams as compared to 3.12. Well, 2.37 is a smaller number. And so the reactant that produced that lower number, the sodium carbonate, is limiting. So we should circle sodium carbonate. Now, students, we in this lab asked you to weigh out a particular amount of sodium carbonate and calcium chloride. So we did this by design. We wanted sodium carbonate to be limited. Question 5. What is the theoretical yield? How did you pick this number? Well, it's the smaller of the two. So we went ahead and showed all the work for the number of grams of calcium carbonate that would be produced if either of the two reactants were to react to completion. And the correct answer is the lower of the two. So 2.37 grams of calcium carbonate, chalk, is the expected theoretical yield because it's the smaller of the two possibilities. Now for the fun part. So in day 2, all we did, so remember 2.37, and then I'm going to erase here. Okay, question 6. We're now on day 2 analysis. What mass of chalk or calcium carbonate did you actually produce? So we'll refer back to our data table. The mass of the filter paper with dried chalk was 12.98 grams. Then, to find the mass of the chalk produced, we need to look back to the mass of the just plain empty filter paper. And that one was 10.8 grams. So subtract, and you'll get the number of grams of dried chalk, calcium carbonate, that was actually produced. And we got 2.18. Question 9. Calculate percent yield, remembering that percent yield is the actual yield over the theoretical yield. So in the day 1 analysis questions, the last one was, what's your theoretical yield and how do you know? It was 2.37 grams because it was the smaller of the two calculated possibilities. Well, here's an easy answer to this question. Our actual yield is what we actually produced. Our theoretical yield is 2.37 grams. So we actually got 2.18. We theoretically should have gotten 2.37. That's actually really good numbers here. And then to make it a percentage, we'll multiply by 100%. So if we take our calculator, I get 0.92. I'm just going to round it to, so 0.92. And then if I make that a percentage, that's a 92% yield, which is hot dang. That's a good number, students. Nice work. Last question says, describe in detail one source of error, just one. And there's actually a lot that you could talk about in this lab. For one thing, I'm not used to getting percent yields in the 90%. I think that's pretty uncommon. So right now, my hunch is that the chalk that we captured was not completely bone dry. I think that it may have been slightly wet. And if it was slightly wet, that would raise the mass of what was actually produced and thereby raise the percent yield. So I'm suspicious of that. Other things that could have gone wrong. Anytime you have a reaction, students, even if it's a quick, fast, and nearly complete reaction like this one, it might not all go to completion. That is to say, you might still have some of the reactants left over. You might have some sodium carbonate left over, even though we, by design, made this lab where sodium carbonate was limiting. There still could be some left. There's any number of other things that you could think about and talk about in the report. Please give me a nice, thorough response in 3 to 4 sentences. Thank you, and good luck with your lab reports.